So the reminder from yesterday is if I have an unknown in my exponent, which I do, if I have an unknown in my exponent, which I do, what can I do to drop that down? I can take the logarithm. So that was what we ended up with yesterday. We used the property that if you see the log of x to the m power, we can rewrite that as m times log of x. And so since the common log is something that is on our calculator, if the x happens to be up here, that's really useful because then it goes down to the front. In order to do that though, this expression would have to be alone, okay? Is the term with the exponent alone yet? It is not. And yesterday it was. So we just went right ahead to taking the log of both sides. So if you ever see that it is not alone, we're going to just use our solving steps to get it alone. In other words, I want to get this term alone on that side. And so I have a plus 3 here. What do you think we're going to do? We're going to minus 3. If there was a multiplication, we would divide. If there was a division, we'd multiply. So similar steps as before to when we solved. So now I have 5 to the 2x equals 4. All right, so we're getting closer. We need this 2x, our unknown, to not be in the exponent anymore. So we're going to introduce the logarithm. So I'm going to take the logarithm. Well, I was hoping that would work, but I don't know what this is. Other purple one. All right, so we're going to take the log of this side, and if I take the log of one side, I need to take the log of the other. So what happens? What did we say is going to happen if I do that? What do you think, Kim? Yeah, because what's happening? Because the 2x is going to come to the front. So now I have 2x times log of 5 equals log of 4. All right, this is all multiplication. So we did run across one of these yesterday. We are going to need to divide both sides by log 5, and we're also going to divide by 2, aren't we? So I'm going to take log 5. I'll do that first just so I can show you how to do it in your calculator. This is the common log, which we said is base 10, which your calculator is going to be able to evaluate for us, even if it's not exact. Would you make sure, though, when you're doing this, you're closing parentheses? All right, so I'm getting 0.861. It says nearest hundredth here, so I'm going to call that 0.86. But I have 2x left on this side, so I have 2x equals 0.86. I need to divide that by 2. So divided by 2 is going to be 0.43, if you can see that. Okay, now, yes?
Do you always divide the left side of it?
I always divide to isolate x.
Like the side with x with it?
Yes, so like when we were doing this yesterday, it's not always on the left side. I don't know if I happened to put them on the left side yesterday. I did. But let's do one that's not on the left side. Like for instance, if I had gotten this, 3 to the x equals 17. I'm just showing. I remember I'm trying to solve for x, so I take the log of both sides. I take the log of 3 to the x, that x is going to come down to the front. So this time to get x alone, I would divide by log 3. Yep, so whatever the side of x is, that's the side you're trying to isolate. Hey, did anyone notice right here that they knew they were going to have to divide both the 2 and the log 5? If you did, you can do that all in one step. Just be real careful on your calculator, because you would have to do log of 4, and then you'd have to do a parentheses to make sure you included both things, divided by 2 and the log of 5. You're going to notice in a second I'm going to get the same answer. Yeah, you can still get the 0.43. So just make sure, if you're going to do it all in one step, totally fine, that you use a parentheses to do that. Okay, so the second really useful thing, and some students will be like, why didn't you teach this to me before, is something that lets you change bases in logarithms. Here is why this might be useful. Let's say I asked you to find the log base 2 of 8. 2, and we could do that, right? What's 2 to what power gives me an 8? 3. Okay. But let's say I asked for the log base 2 of, I don't know, 11. Do we know an exponent of 2 that's going to give us an 11? We don't. So right now, the only logarithms we can evaluate are common log, because we can use our calculator, or logs of other bases that we know exactly. The change of base formula is going to let me change things to a common log so I can figure out what something like this is with our calculator. So here's how it works. If you have the log base b of, I'm going to call this a. To change the base to common log, what you do is you take just the common log of a and you divide it by the common log of the base. Okay. And then common log is something that I can put on my calculator. All right. So let's try a couple. We're going to use the change of base formula to express log base 2 of 20 in terms of common logarithms. Then we're going to round to the nearest thousandth. Okay, so in our heads, 2 to the third is 8, right? 2 to the fourth is 16. What's 2 to the fifth? Somebody just maybe you know, or 32. We do not know exactly 2 to what power gives us 20. But would you agree it has to be something between 4 and 5? Because 2 to the fourth is too small, 2 to the fifth is too big. What we can do to find it is we're going to do the change of base. So I'm going to change it to common logs. So I'm going to take the log of 20. Here's how I remember this. Does anyone have a basement in their house? Okay, where's your basement? Just point. I remember that the base goes in the basement. That's how I remember change of base formula, okay? That the log of the base goes in the basement. So I'm going to divide that by the logarithm of 2. All right, let's do that on our calcs. Common log of 20 divided by common log of 2. And what did I say? Nearest thousandth, so I'm going to call that about 4.322. Okay, let me explain to you what I just found. Didn't we say 2 to the fourth was 16, too small, 2 to the fifth was 32, too big. We just found the exponent of 2, that is 20. And if you don't believe me, watch this. I'm going to do 2 to the, and I'm going to store my answer, and it should give me 20. Okay, so that's what I just found. You guys have seen the answer key before? It just takes your previous answer. Okay. All right, would you try this one? Log base 6 of 8. Would you rewrite it in terms of common logs and get an answer to the nearest thousand? do a check-in. So the common log of 8 divided by the common log of 6 is 1.161. Can you give me an indicator? We good with that? Okay. All right, so here's why I don't do change of base earlier, because I think you guys really, better than my pre-calculus students right now, you have a great understanding of what a logarithm is. And I think it's because we spent all that time doing them without this shortcut formula, okay? And that's important to understand what it is. But it is definitely super useful for other bases. So, all right, here's what we're doing.